am the founder and CEO of Quantum AI Global. So, past 2 days we have been hearing a lot about AI and the future of AI, how disruptive AI is, and all the good stuff. But there's a new technology which is evolving, which is called quantum technology, and I'm here to create the awareness. Me and Kapilji, we are here to create the quantum awareness. So we had a specific set of questions prepared, but I have interacted with a bunch of students yesterday, and they really had a lot of questions. So how I have designed this keynote interview is to create the quantum awareness. We are not going to talk what products we are making or the future of quantum, but just basics of quantum. So I'm going to ask you, Kapilji, as a final year AI student, and I want you to answer me about quantum technology as a student, not as a businessman or anything, right? So to start with, what is this quantum technology in one line? And, how do you explain quantum and why it's so disruptive?
So a very good afternoon to you. As Sanjay brought out, what's the quantum technology which you want to explain to a student which is just coming out of BTech or undergoing the BTech? So my particular perception is all these people of quantum scientists and other people have created an aura around this particular subject. The application of that subject is not that complex. Even the understanding of that subject with the standard analogy of the other mainstream computer science or telecommunication subjects, always an analogy can be created. So what quantum does, it from the computing domain, it gives us a flexibility to process higher data, higher dimensional data into a much simpler manner. So if I look at it, so we had a CPUs earlier. When the data became more, we have a GPUs. Similarly, when the data becomes further more and further complex, we will have a quantum computer. So it's a natural progression of the computing technology which is evolving. The quantum technology as such at the physical level, yes, it may be difficult to understand as a physical researcher who is working on the physics level. But for the people who are going to use this technology, it's just a natural upgradation of the technology from, I'll say, CPU, GPU to the quantum computer. So that's how I look at it. That's how it is simple as it is. It is going to be something which is, presently sometimes people feel it's very complex. It is going to be after some time, it's prevalent and it's available to the standard users over the cloud. That's how it is going to be.
So, is there, am I right in saying, like, is there a comparison between AI and quantum, or is there an integration between AI and quantum?
So both of them are technology which are actually complementary. So that as of now, there are problems in AI which can not be solved with the today's availability of the computing power or the memories which we have got. With the advent of the quantum computers, these problems will be solvable. So as of now, stage one, the quantum technology is helping AI. Secondly, now once the AI model, once you have the quantum technology available and you can run, similarly the quantum computers can help us design the better AI models. So in this scenario, it's like the two technologies which can self-perpetuate the innovations in bidirectional way. So quantum pushes the AI ahead and AI pushes the quantum ahead. So they are kind of complementary technologies, and the integration of them is going to define the way we progress on this.
So in one line, if you have to explain what is quantum, would it be something like quantum is extremely fast and extremely secure? Would that make sense if you have to describe quantum in one line versus AI?
Yeah, so if you have to describe quantum is extremely, I'll say, compute side, it's very extremely fast, and the communication side, it gives you a complete secrecy. So these are the two things which it can provide.
So where are the applications of quantum? We know AI, where all it could be used. So where all the quantum could be applied?
Okay. So starting from the AI side, so we, all of us who have been into the AI, we understand that AI theory was available in 80s. It was kind of matured in early 90s and 2000. However, the ecosystem of the computing power, the ubiquitousness of the mobile devices, those were the factors which are now propelling the AI were not available at that time. Now we are at the similar stage in the quantum tech. The technology has evolved, the quantum computers are improving. However, the complete ecosystem is still at distance at 2-3 years away. Probably that is the time when that ecosystem develops around the quantum also, and it gets integrated at the back end to our clouds or our data centers. The way we are seeing the hype in AI, or the way the AI is becoming very, very usable, and it's everybody who wants to work in AI, a similar experience of the quantum will also starts happening.
So this particular question I'm asking on behalf of those college kids. One of them I think I met at the stall. All over Google, all over YouTube, there's something called this quantum threat and Y2Q. What is this quantum threat, and is it really threat, or could you take some time and explain why quantum and what is this threat about and what's the solution?
Okay, so if you look at the quantum technology, it is going into two directions. One is a quantum computing, and second is a quantum communications. Okay. Now, quantum threat, the way it is emerging, a good quantum computer which is error-free and noise-free, and at a certain amount of capacity. So the capacity is like this: we had 8086 processors, we had 286, 386, Pentium, we have i3, i5, i7. So your processor generations were evolving. Similarly, the quantum computers, we had 10 qubit computers, 100 qubit computers. Now we are talking about the 1000 qubit computers. There is a boundary line somewhere around 3000 qubits. Once we reach that benchmark, the present generation of the cryptographic systems which the world is using all over, they will become susceptible to be cracked by these quantum computers which are around 3000 qubits. That's the world is looking at the quantum threat, or the Y2Q. At that time, the internet as we know it becomes very, very susceptible to disruption. There will be chances that the bad actors or the hackers, they access our data which is transiting over the routers, over the internet. They capture that data, and they also are able to decode the data or decrypt the data, decrypt the data using the quantum computers. And these quantum computers even today are available online as cloud services. So if the sufficient capability quantum computers are available online, and they are sufficient, the computing side, they are sufficient to break your present generation of encryption systems, the internet transaction, our banking transactions, our security of the emails, the way we interact with the social media, where we are putting some guardrails onto that, all that becomes susceptible to the hackers. It becomes visible to them. So that's the threat which is there sometimes in future. So probably they say, some people say 5 years, some people say 3 years, but you never know. Somebody may come up, there are a lot of people who are working on the quantum field, trying to develop new computers. It may happen anytime. It may happen in next 2 years, it may happen in next 1 year, you never know. The second threat which is associated with this is like the data, some of the data which you are transmitting over the internet, it has a long-term value in terms of secrecy. I do not want that data to be probably decrypted even in future. So it may be a personal data, it may be company's data, it may be data which say some of the important organization of a nation state are using. That data can be now captured, stored by these bad actors and subsequently decoded when the quantum computers are available. If that kind of a threat scenario is emerging, this is called harvest now decrypt later kind of a threat scenario. So this is a particular threat which needs to be addressed today, because as of now the data which is flowing on the internet is susceptible to the quantum attacks of future. So that is where the threat lies.
So considering the time and the minimum audience, one last question. How many countries have adopted quantum technology and where India stands as of current date?
Okay, so adaptation of the technology wise, we think approximately 15 odd countries which are into this game. $30 billion is kind of being invested in next 5 years. China is in the front runner with an investment of around $15 billion. US with around $4.5 billion is the second. India ranks somewhere around with our national quantum mission committing around 6,000 crores. So we are somewhere around $10 billion, $1 billion. We are somewhere 10th or 11th in that game. So we are there. We are not the front runners, but we have made a start into this through NQM. And with that NQM, mostly I think the education institutes will also start getting into that mainstream. So quantum will start becoming the mainstream as far as India education system is concerned.
Professor, thank you.